Hey guys, so I wanted to take this question and talk to you about the uniqueness of diverging mirrors and diverging lenses. So diverging mirror, which is also a convex mirror, and a diverging lens, which is also a concave lens, both have the uniqueness in that they will always create virtual, upright, and reduced images. So on this left side here, we've got 7 different scenarios in the mirror, and all 7 of those scenarios create a virtual image that is upright and that is reduced. And the pattern too to notice is that as the object gets closer to the convex mirror, the image on the virtual side of the mirror, that is the opposite end of the mirror, is going to step away from the mirror as it gets closer. I'm sorry, it's going to step towards the mirror as it gets closer. So as you step towards the mirror, so let's say that you're on this end of the mirror. So as you step closer towards the mirror, the image also steps closer to you. And so it gets larger. And then in the concave lens scenario, as it's also on the virtual end, because for the lens, the virtual end is on the same end, because when we look through a lens like a magnification lens, we expect the image to be on the other end. So we call that the real. We call this the real side, and then this is the virtual side. And this is the same scenario. As you step closer to the lens, the image also steps closer to the lens. Except for now it's on the same side. It's all occurring on the same side for the lens. But when you get a question like this, a conceptual question that what describes the image of a convex mirror when an object is x distance away from the mirror, it doesn't need to tell you the distance or whether it's on the focal length, on the opposite end of the focal length, because it will always create a virtual, upright, and magnification less than 1 image. So for me personally, if I remember a convex mirror, then that helps me remember all the rest, and I'll show you how that is so. So if I can just remember for myself that the convex mirror is the one that creates the virtual, upright, and reduced image, then the opposite of that, the opposite of convex is concave, and the opposite of mirror is lens. Then this concave lens also produces virtual, upright, and real images, and both are diverging. So both are diverging, and both create virtual, upright, and real images. At that point, I need to remember that mirrors, so if this is a mirror, and that's a convex mirror, then I also need to remember that the virtual side is on the opposite side of the mirror, because that's where we see our virtual images. And then if it was a lens, if it was a concave lens, then I gotta remember that the same side is the virtual image, because I would expect in reality for a real image to appear on the opposite end of the lens. And then one more thing that's important for these guys is that they both have a negative focal length. So when you're doing the if I do I die equation, you'll always use a negative focal length for these two, convex mirrors and concave lens, which isn't necessarily given to you in questions. Sometimes they'll just give you a focal length of 21 centimeters, let's say, and they don't tell you that it's negative. You have to understand that you have to plug that in there as negative. So again, if I could just remember convex mirror, then I can think of the very opposite of that, which is concave lens, and I know both of those are diverging. And then from there, I would think of the opposite of a convex mirror. It would be a concave mirror or a converging mirror, and that follows a different pattern. Same thing with a convex lens, that follows a different pattern that we'll talk about in a different video.